Okay, so I had a little boo-boo back on example 8. This is why recording all the videos on Sunday night is a bad idea. All right, so the boo-boo is not in any of the work. I forgot to produce the second answer. Inverse cosine will only ever provide us with numbers from the first and second quadrant. I need to find the equivalent fourth quadrant angle that goes with the 1.26 we found. So, since what we were doing the inverse cosine of was positive, we know this is a quadrant 1 angle. Plus 3.14 pi, half of that's 1.57. This is less than 1.57. So this is in quadrant 1. And then cosine is also positive in quadrant 4. Now I know in the book there's a handy dandy sheet that tells you how to convert, like if you know the reference angle in quadrant 1, how to get the equivalent angle in the other 4 quadrants. Like I never remember those things. So this is our (1.26 radians. I want the one in quadrant 4. So that measure is 1.26. This measure is also 1.26, but it's negative. Because I drew the angle the other way. But if I take this and add 2 pi to it, then I'll get the quadrant 4 angle. So negative 1.26 plus 2 pi, and we are literally going to be adding the decimal 3.14. Because we don't have some pretty in terms of pi numbers, so we're not going to have the other one just written as negative 1.26 plus 2 pi. We are actually going to calculate that out. And that is 5.02. So that is our other angle. That is the quadrant 4 angle that will also produce a cosine equal to 0.302775, blah, blah, blah. So up here, theta is that, but theta is also 5.02 plus 2 pi k. So our full answer should have both of those angles. Been a while since I had to work so many of these. My apologies. But unless you're doing like where's cosine or sine 1, you're gonna get 2 answers. So I should have actually like had the thought in my head like that's only 1 answer, there's usually 2. So yay, mistakes, we learn. And all right, now this one. Sine squared equals 2 cosine theta plus 2. Why? Because they could. All right, so sine squared, but everything else is in terms of cosine. There's not a good way to turn regular cosine into sine, but sine squared, that I can interchange for cosine squared with one of our favorite identities. Which identity has sine squared and cosine squared? Thetas. Now put theta and put a plus, and it equals 1 because that's the Pythagorean one. So I want to know what is sine squared in terms of cosine squared. So sine squared is the same as 1 minus cosine squared. So I'm going to write that instead of sine squared. For me to solve this, I need it all in terms of the same trig function. So that's what the hint is. So now instead, this is 1 minus cosine squared theta equals 2 cosine theta plus 2. And now, of course, it's a quadratic. Since the squared term on the left is negative, I'm going to take both things on the left and add them to the right. So we're going to minus 1, which is actually like terms with the plus 2. And then we'll add cosine squared. And I'm kind of like writing it in front here because it's not like terms with the cosine. This does not become cosine cubed. So this is now 0, which is what we need for quadratics, equals cosine squared theta plus 2 cosine thetas plus 1. Now, it may not look like it yet, but this is actually a perfect square. U squared plus 2u's plus 1. This is u plus 1 times u plus 1. So I said each one equal to 0, I get the same thing. U equals -1. So cosine theta equals -1. Where does that happen? There's our cosine graph. Third point in, that's 0, pi over 2, pi. So this is when theta equals pi plus 2 pi k. They said answers between 0 and 2 pi, so this one is just one answer. But like I said that only happens when it's the extremes, when it's 1 and -1. Everybody else has 2 values. So that is our only answer due to that restriction. Okay, we got this. We can do it. All right, this one's going to have a little more interesting stuff for us. All right. Yeah, I got plenty of room. All right, so that 2, I know it looks a little funny in the typesetting in the book, but that is 2 times sine squared plus sine equals 0. So again, ugly is my best friend here. So this is 2 ugly squareds, because we're saying ugly is sine theta plus ugly equals 0. Now, this is a quadratic, but there's no constant term. So what this means is when I look at these two terms, they have something in common right now, a u. I'm going to factor that out. Too much talking. All right, so u times 2u plus u times 1. That's factored. Sweet. So one of these is going to be u equals 0. And then the other one is 2u plus 1 equals 0. So -1, 2u's is -1, divide by 2. So u could also be -1/2. All right, so we're going to bring it back to our substitution then. This is asking, when is the sine of theta equal to 0? And when is the sine of theta equal to -1/2? All right, so sine of theta equals 0. If I think about my graph of sine, well, it equals 0 at 0. And then that's our +1 at pi over 2. Our next 0 occurs at pi, 3 pi over 2, and then 2 pi. But 2 pi is just 0 plus 2 pi. So this is going to give me theta could be 0 plus 2 pi k. Theta could be pi plus 2 pi k. Now technically that could all be written as one statement, but Again, I just generally write it as 2. Now, where is sine negative 1/2? All right, so 1/2 is long, short vertical, long horizontal, short vertical, which is the smaller angle. So this is 30 degrees, which is pi over 6. That's literally the entire chain of thoughts in my head. All right, but we want negative. So not the 5 pi over 6, but I want 7 and 11 here, because that's where the sign is negative. So theta is 7 pi over 6 plus 2 pi k. And 11 pi over 6 plus 2 pi k. So now rewind. Yep, they gave us 0 to 2 pi. Oh, you sneaky little jerks. That should be a typo. Normally, we do not include the 2 pi because it's coterminal with 0. Listing them both is redundant. But because they put the equal, even though it might be a typo, technically, we need to include 2 pi in our answer as well now, only because 0 is in our answer. So, yay for weird typos. So we have 0, pi, 7 pi over 6, 11 pi over 6, and 2 pi. Now again, normally you would not put the 2 pi. Normally that does not have an equal bar. Here it does, so we'll put it, because this technically answers the question as asked rather than what the assumed intention would have been. But if I had given you a question like this and you didn't write the 2 pi, I would not take off points for that, because that to me is an assumed, like a normal assumption to assume that it shouldn't have been underlined there. All right, so we're going to stop that video, do yet another. Told you this was long.